Powerful collaborations, cutting-edge science, and curious minds coming together for a glimpse of the future. Stay tuned as we look at the latest updates on some of the most promising technology projects. Welcome to the EUVATION podcast. Today we will speak with Olof Eriksson from Veoneer, a world leader in automotive safety products. He brings us up to date on the Car2TERA project, in which he is a consortium partner. This European Union H2020 project is making strides with in-car sensing using terahertz frequencies, which will aid autonomous driving and crash safety. Welcome, Mr. Eriksson, to our podcast.
Thank you.
Car2TERA started, about a year ago?
That's correct. Early 2019, yes.
And can you just give us an idea of what Car2TERA is all about? And when I say what is it about, I mean, for the average person, why is Car2TERA important?
So in Car2TERA, we are looking at two different applications. And one is an automotive radar, a car radar. And the other one is a high-speed data link based on fiber connections. So from my side, I'm looking at the automotive radar. And why it's important is because in the future, when we're going towards autonomous cars, we will need to have much more knowledge about what's inside the car and what's outside of the car. And we need to have, it's not like pictures, we need to understand what is going to happen in the next few milliseconds or seconds. So we need to have a very accurate sensing, and the radar is a good solution to this.
It seems like most times when we say radar, people might be thinking outside the car, but you're focused specifically on the inside.
In this case, for Cartooterra, we decided to look at the inside of the car, the in-cabin monitoring. And the reason is that currently there is a lot of interest in this in-cabin monitoring, and the solution today is based on cameras. And although they are very good, they don't fulfill all the requirements. So we want to see if there is some other solution, technical solution, that can do this.
Okay, and your interior sensing equipment is at a special frequency, something that is relatively new in car radar technology.
Right. So we're looking at 240 gigahertz. Today, most radars are working at 77 gigahertz. So this is a dedicated automotive radar band. So it's allowed worldwide. We think that there will be a new band that will be allowed soon at 120 gigahertz. But in Car2TERA, we are actually looking at 240 gigahertz. And there is a reason for this. The higher you can go in frequency, the smaller the wavelength. And the wavelength is very important because it tells you two things. Either you can make a very small sensor because the size of the sensor is proportional to the wavelength, or you can make a sensor that has a very good resolution. Resolution is important, but a resolution in angle. And you need the antenna size, you need to get good resolution. It's also proportional to the wavelength. So for both of these cases, either a small sensor or an antenna with very high angular resolution. Okay, I'm getting very technical here, but with this high angular resolution, it helps to get it to a smaller wavelength. That means a higher frequency. And maybe in the future we will go even higher, but for now we want to see, is it possible to actually make a product that works at 240 gigahertz, and what performance will it get? So this is what Car2TERA is about. And the high resolution that I'm talking about is needed inside the car because we are looking at people sitting in the car, and we don't just want to measure or detect that there's a person there. We want to actually see all the parts, like a picture, a camera picture of the human with the radar. So the high resolution, let's call it many pixels, is important in this case. And we can achieve this at 240 gigahertz.
And I guess people might be asking, why do they need to know what's going inside? Why do we need to know how many people and what position these people are in? Can you give us a scenario where this information is important in carrying out some sort of task?
We're talking about the applications and we're talking about use cases. So the applications in the car, it's in-cabin monitoring consists of many applications, and one could be driver monitoring. So we want to know, what is the driver doing? Is he attentive? Is he driving the car actively? Can we trust him? But we also want to see if his head is turned forward so that he actually is looking on the road, or if his hands are on the steering wheel. Because all of this is important for the, let's call it advanced driver assistance system, where we help the driver. So if we know that his hands are not on the wheel, we can either warn him, tell him to put them back, or we can actually do some active control of the car, like lowering the speed or even drive to the side of the road automatically. We also want to see his physical status. Even though he might be looking forward, he might be very tired. And if we can measure, for example, his heartbeat or breathing pace, we could do some conclusions on how fit he is to drive the car. There are additional applications which are called seating positions. And this is when we activate in a case of an emergency, in case of a crash, we need to activate passive safety systems like airbags, seat belts, and so on. And we only want to do that where we know that there are people and that these people are sitting in the right position, so that we don't make things worse with activation of these passive devices. So we want to measure what are the positions of the driver, of course, but also of all the passengers in the car. And there are also these, what you have already today, when you sit in a car and you don't put on your seatbelt, you get a warning. These systems today are actually very expensive. And if we can do this with the radar, we would actually save a lot of money for the car manufacturers. But we could also have a more robust system, so we can distinguish between a box which you put inside a car, or if it's a human sitting there. And if it's a human, obviously we need to tell them to put on the seatbelt.
Your work in this project is at 240 gigahertz. Is there a limitation to this? Is there only a certain range where you can do testing right now? Is there some sort of regulation involved with this?
Absolutely. There are different legal or advisory committees all over the world, and the ITU is the main regulatory body. That's the International Telecommunication Union. And they recommend which frequency band should be used and for what they should be used. At the moment, the 240 gigahertz do have a band that we may use for testing, but this band is kind of limited in bandwidth. So we want to use a wider bandwidth for the final application. So in Car2TERA, we do have some tasks which include informing the regulators about the possible performance advantages that we can have with this wider bandwidth, and we would like to influence them to actually give us this wider bandwidth in the future, so that we can have this Car2TERA sensor in every car everywhere in the world.
Okay. And you mentioned this Car2TERA sensor. Is this a product of the project? Is this something that you will build, something that will you have a demonstrator at the end of the project?
There will be a demonstrator both for the radar and for the fiber link, communication link. For the radar, we will do a demonstrator that can be put in a real car. And we will test this demonstrator in two different setups with real people. So we will have a mock-up car initially that we will put the radar in, so we can verify the basic performance of this radar regarding all the qualities that we need, what I talked about earlier, the high resolution, but also the accuracy in range and actually the position of the persons that we're looking at. And then we will integrate this radar in a real car so that we can have demonstrations for car manufacturers and other interested parties.
Okay, and the company that you work for, which is Veoneer, this is kind of what they do, right? So you're at home in this arena.
Yes. So Veoneer was split out of Autoliv 2 years ago. Autoliv is still doing the passive safety devices like seatbelts and airbags, but Veoneer is doing only active safety devices. So we build systems with sensors and software that makes a perception of the world around the vehicle and as well as inside the vehicle. And based on this, we take decisions that helps the driver. Either we warn him if there might be a dangerous situation, or we actually can help him to some extent in case of automatic emergency braking or blind spot warnings. So there is something called SAE levels. SAE is this Society of Automotive Engineers. And they have recommended different levels of autonomous driving. And level 0 is basically only warnings and some momentary assistance to the driver, where we actually can push the brake automatically. And today, most of the sensor systems are working in this. Eventually, we'll go to level 5, which is a completely autonomous vehicle, where you do nothing as a passenger in the car. The car drives completely by itself, everywhere and anytime. This will not happen within the next 20 years, but at some point we may get there. So today we are actually working at what's called the level 0 to level 2, where we take over the car more and more, but the driver is still completely responsible. And Veoneer is developing all the sensors that are being used in these systems, as well as all the processing platforms that's in the car.
Okay. So Car2TERA is not necessarily addressing the idea of self-driving automobiles, but somewhere between this level 0 and 2, which is the automobile offering a little bit of assistance to the driver.
Right. So what will happen is that we add more and more sensors, and that's required to increase the level and this SAE level of autonomy. But of course, the in-cabin monitoring will be part of the final solution when we get to level 5, when the car is driving completely autonomous. So we need a sensor, but it will not solve it by itself, of course.
Right. Okay, and one thing that's always interesting is to look at the use cases in projects like these, because this sort of always brings the point home. Many of our listeners often have questions, how does this fit into our society, or how will this affect me? So in this way, projects with use cases tend to have a little more interest for the everyday person who's interested in technology, perhaps. So can you talk about your use cases? Is this anything that we can relate to?
I think so, yes. So we're talking about applications and use cases. And for each application, there might be different use cases. But what we identified for Car2TERA and the applications that we actually choose for Car2TERA, which are the driver monitoring, the seating positions, and which I haven't talked about. The child left in car application is actually when you as a driver have left the car and you maybe have forgotten that your infant is still in the car, and we need to detect that this is happening. I mean, it's a huge problem in some countries like US. But coming back to the use cases, so for the driver monitoring, for example, we have what we call the normal driving, which is where everything is fine and you're driving on the road to work, for example. And you do a lot of maneuvers still. You're turning your car and you're looking in different directions. So it's a complicated use case where you need to identify what the driver is doing. The second use case is pre-crash, and this is within a second of or before you actually impact something. And in this pre-crash use case, you really can't do much with the car by itself. You can't do any evasive maneuvers. So what you can do in that case is try to prepare all the passive safety devices. You will not activate them yet, but you can lower the thresholds to make them more sensitive. And after that, you get in a use case which is called the in-crash. This is with high physical energy going into the car, high brake forces, and so on. And the body of all the passengers will be moving rapidly. So you need to be able to measure the speed of the bodies inside the car very accurately at this time. And now, if you're done everything right in the pre-crash use case, all the passive safety is sort of on standby and can be activated very rapidly. So the airbags can be deployed rapidly and with the correct force to stop you from moving into some hard parts of the car. And sorry, there's one final use case. Then the final use case is the post-crash. So after you crashed, we would like to use this radar to actually check the physical status of everyone in the car. And that means that we want to check if everybody is still in the car. So when you entered the car initially, we measured you with the radar with this seating position application. So we know that there were, for example, 3 persons in the car. And after a crash, we want to know if everybody is still in the car. So no one has been thrown out of the car. We also need to check the physical status of people if they need medical care. So we can do that by checking the heart rate or the pulse rate. And then we will send this information through an emergency call. In Europe, this is called an e-call, and a lot of cars actually have this already. So what they do is they send the GPS position of the car, and then they send the information that the airbag and seatbelt sensors recorded during the crash. And we would like to add the physical status of the people in the car to this e-call.
Okay. Are there any health hazards to constantly being monitored by radar in your car, for example? Perhaps you're in your car all day long. It's part of your job. Is there anything to look out for?
No, absolutely. This is a difficult question. So 240 gigahertz is really high, and there's not been a lot of measurements at these frequencies with respect to health. There are regulations and recommendations, but these actually end around 120 gigahertz. So there has to be some sort of extrapolation of these values at the moment. And if we look at these extrapolated values, we are way below this health limit with the 240 gigahertz radar. So I'm not concerned about the health risk as such, but of course, it will be the same discussion as with mobile phones. So for long time exposure, does that have some sort of impact? And this is part of the work that we're doing in Car2TERA, is to look at this, to try to find more information or to propose additional measurement in the future to verify that we don't have any health hazard due to this.
Okay, but this is something that's always on your mind, right? This is part of the process. Safety for the end user.
Absolutely. I mean, it's both the user has to feel safe. So it's not just saying that we are below any recommended levels. It also we have to show the user that he can be using this without any worries that it will impact him or any other users in the car, small children and so on. So absolutely, it's constantly on our minds.
And how long does this project go? As we said, it's been underway for not quite a year, but is this a 3-year project?
Yes, that's correct. So at the end of 2022, we will integrate the radar, as I said earlier, into a vehicle, and we will demonstrate this for both internal and external stakeholders. So the pre-development teams within Veoneer and also car manufacturers.
Well, it sounds like there are good things in sight for Cartooterra, but still plenty of work to do.
Yep.
Best wishes, and we'll stay in touch for regular updates. Thank you for taking the time today. Appreciate it.
Okay, thank you, Peter. It's been very nice talking to you.
This podcast has been brought to you by Technicon. The project leading to this application has received funding from the European Union's Horizon 2020 Research and Innovation Program under Grant Agreement number 824962.